Hello, welcome to the back of the shop here on Tech Tuesday. What's going on is we brought a wheel to the back to get away from our user here with the wheel to do some repairs. We're going to show you a repair that we're going to try and get away with. Sometimes you do things that you're not fully as thorough as you'd want to be, but this user here insists they've got a ride this afternoon. They planned on it their whole week, so they just have to have it. So we're going to try and do some shortcuts, get in their wheel, and hopefully we get it back later and can really get inside and do a better job. But what's the problem? Let's see what we got here. So on this wonderful wheel, let's take a quick diversion and have a look at this. Lovely color to begin with, but check, it's the hub. It's a normal mountain bike hub, a 135 spacing. Can we see the spokes are all to one side? That looks funny at first. Why? They just use the one side. That's true. On this wheel, it's built asymmetrically. So they've put this extra extension to the left. This is an early fat tire wheel, the early big tire bikes from the old pioneer days. The very early ones didn't have the wide hubs. We don't have the 197 hubs, the 170 hubs, really wide flanges. This is your standard mountain bike hub. It's what was available. They got the wide rim, they made it work, big tire. That's what it was back then. Now, back to today. The problem is not that, it's the hub and it's this. This is just a steel dropout. It's like the type that's on the bike. So to show you what's going on, check out all the threads here and then check out the hardly any threads over here. This thing is sticking out way much over here. So first, why is that a problem? If this is on the bike, we can see that the threads, they're sticking past the dropout. Well, when you close this cam and you close that skewer tight, it can feel tight, but you're going to be closing not on the bike. You're going to be closing on the end of the axle. All right, so that's not going to hold the wheel in. The skewer needs to be securing to the frame, and that's not going to happen with that long axle sticking out. Okay, now on to number 2 here. What happened here? How did that creep? Did that grow longer? Did that axle magically move over there? I don't think so. I think it's likely this is how it was put together.
Hi there, Dane, video editor and owner of that wheel. Just needed to pause the video quick and let you know that I think Kelvin is mistaken. I did not put the wheel together that way and don't know why it's broken. Anyway, back to the video.
Another day for that. Important thing, they're waiting to get on their ride. So, to fix that, we gotta first take the skewer out. We're gonna get some basic tools here and try and take a shortcut. Sometimes shortcuts can work. Sometimes you do a shortcut, it ends up taking you a lot longer to get to your destination. We all know that. So step 1 here, how much axle, when we're going to recenter this, do we like to see on each side? So one way to do this is count the number of threads. This is a 10 millimeter diameter by 1, a 10 by 1 thread. Each thread is a millimeter, 1, 2, 3 threads here, and I could count here and take the average. Or we can take a caliper. We can see the extension here, 8.5 millimeters sticking out here. Let's add that to over here. 2 millimeters, 8.5, let's call it 9. 9 and 2, 11. So about 5.5 millimeters on each side is what we'd like to see. Does not need to be exact, but it certainly cannot be as off as it is now. So 5.5, we'll try and 5 fingers plus a half, that's how many millimeters I need. So now what to do? We have a cone wrench and a wrench for the lock nut. Cone wrench is for that thin nut fitting on the inside. The cone has a narrow wrench flat, and then on the outside is this lock nut. I can break that free And I'm going to back that off. I probably need to take it off entirely. I noticed the orientation. This one makes sense. No teeth and teeth. Teeth bite the frame. Teeth go into the steel frame to hold it. We have a washer. It is symmetrical. And here, I may need my axle vise, but I'm going to try and turn the cone hold. Lucky. My shortcut is going pretty well so far. Sometimes it's real sticky and I need to grab that in the axle vise, but we lucked out. So I'm going to back off the cone a bunch. I'm not going to take it out. This is not about an overhaul. So that's backed out a lot, and the reason is I need to get to what's called the cone on this side, so I'm going to shove that through. Sometimes this prevents a seal from escaping. In this case, lucky, we're working out okay. The cone I can get to, now it's past there. This seal sometimes is larger than the lock ring here, and you have to take the cassette off. So far, our little shortcut, right? Kind of cheating here, we're doing okay. Now, with the cone exposed, I can get in there to those wrench flats. With a cone wrench, are you cone flats right there? Then I can break free the lock nut and I can change the axle as it sits in the hub. And that's what we're gonna do. So, take the cone and we're gonna turn in our case, the drive side cone inward. We're going to run that in, and this is where our measurements count. We're looking for 5.5, right? Soft numbers, soft. Okay, 5. I've got 5.52, close enough. I engage here. I can actually back up a little bit. That bumps the caliper right there. We are close, right there. Close enough, certainly. So now, this side's going to be good. And we're going to get this on the cone. And here, I'm going to hold the cone with my fingers. I'm going to back up the nut. There we go. Now let's tighten. Tighten. Rather than bring the nut down, we brought the cone up. This is tight. This acts as our fixed side. I know that that's tight because this is kind of fun here. Once I draw it inside, I can't get to it anymore. That's why we're concerned to get that tight. Okay, good. Clean it up? Yeah. No, not this time. We would like to, but take it fully apart. We're trying to be careful with the grease. We don't want grease on the rotor, that's true. Trying to be very careful. So we're going to have a quick peek. Same, pretty close. We throw it in the bike. Here's our theoretical bike. We are not sticking past the dropout, so we are totally fine. That is a good fix, so. And now we adjust. So here we're looking for just a little bit of play, very, very little, because you're gonna get some compression, some flexing from the skewer. And I think we were lucky on that. That was just lucky there. Sometimes you do have to go back and forth with the adjustment. That's nothing but dumb luck that it was on the first setting. I will accept dumb luck. Thank you, dumb luck. So it's tight. It's got good protrusion. It is going back in here. They can get on the way. Get this on the bike. They're gonna have a good ride. And I'll say, you know what, didn't look too clean inside. Bring it on back and we'll do a good full overhaul, because yeah, plenty of other stuff going on. But for now, that's it for Tech Tuesday. on a quick fix in a shortcut. See ya next time. Thanks for watching. If you enjoyed Tech Tuesdays, check out our Repair Help video library, which has detailed guides to a wide variety of common bike maintenance procedures. And of course, be sure to subscribe to our YouTube channel for the latest videos from Park Tool.